Right, hello everyone. So welcome back to this particular short lesson where we will go through percentage purity. Now, percentage purity can be found from page 6 of worksheet number 7. Now, this is the same worksheet that has percentage yield. So yesterday in class, we have already completed percentage yield, and I hope you have practiced using the checkpoint questions from checkpoint 1 and 2. Now let's move on to a different concept related to percentage, and this is called percentage purity. So if you recall, we have gone through this word pure when we went through elements, compounds, mixtures earlier on. We have learned that mixtures are impure. And it so happens that many things, many natural substances and materials around us are impure. A very good example is actually rocks and stones. So in particular, Jurong. So all of us, we live, we study, we work in Jurong. But Jurong, the soil in Jurong is mainly made up of this rock called limestone. Limestone is the main rock found in the soil in Jurong. Now, limestone is mainly calcium carbonate, which is also stated here, of course. Now, the key word here is mainly. This means that limestone is not pure calcium carbonate. Limestone is perhaps about 80% calcium carbonate and 20% something else, some impurity. The most common impurity inside stones and rocks is actually sand. And you have learned this before. Sand is silicon dioxide, which has a giant molecular lattice structure. All right. So, how will scientists approach this question? How pure is the limestone in Jurong? Is it 80% pure? Is it 70% pure? Or is it even 95% pure with calcium carbonate? Now, to find out the answer to this question, how pure is the limestone, we need to make full use of our knowledge of chemistry. Specifically, what is the chemistry? What are the chemical reactions of calcium carbonate? Now, because it's a carbonate, we can think that it will react with an acid. And indeed, calcium carbonate should react with acids to form salt, carbon dioxide gas, and water. And therefore, the process by which scientists will go about finding out the purity is number one, let's obtain the rock samples and grind them into a fine powder. The purpose of grinding into the fine powder is to increase the surface area to volume ratio for faster reaction. Imagine if you did not grind the rock up, if you didn't grind the stones or the rocks up, they will take very, very long to react with the hydrochloric acid, even though they do contain carbonates. So the idea of grinding is always to increase the surface area to volume ratio for faster reaction. Now, the next step is to react the powdered rock sample with something which only reacts with calcium carbonate. And the best example is hydrochloric acid. Any acid, such as hydrochloric acid, will react with the carbonate present in limestone. And of course, based on the amount of hydrochloric acid, you can actually use mole concept, mole ratio to work backwards to find out what was the number of moles of calcium carbonate and hence what was the mass of calcium carbonate present in the sample. Once you have worked out the mass of calcium carbonate in the sample, to find the percentage purity of calcium carbonate, all we need to do is to take the mass of calcium carbonate. So in this case, the substance I'm talking about is calcium carbonate. So we take the mass of calcium carbonate in this example divided by the mass of the whole rock times 100. This will tell us how many percent of the rock was actually calcium carbonate. So the idea really is find something that only reacts with calcium carbonate and doesn't react with other things in the rock. After that, use mole ratio, work backwards to find out how much calcium carbonate was there in the rock. Take that mass of calcium carbonate and divide by the mass of the whole rock sample times 100. Now let's look at a work example to make this clearer. So this work example is about limestone. So again, let's highlight numbers, chemical names, numbers. Now, this is very crucial. All right. So now that I've highlighted my chemical names and numbers, I know this is limestone. Limestone is impure, it's not pure. It contains calcium carbonate. And I'm reacting it with hydrochloric acid. And therefore, this is the reaction between calcium carbonate and hydrochloric acid. First step in mole concept is always the balanced chemical equation. Calcium carbonate is CaCO3. Hydrochloric acid, HCl. The salt form is calcium chloride because you use calcium carbonate, calcium, and hydrochloric acid has chloride, so it's calcium chloride, CaCl2. Must remember Ca is Ca2 plus, and Cl is Cl minus. And CO2 gas is formed because it's a carbonate, and H2O, water, is formed. To balance the equation, I need a 2 in front of the HCl. So this is the balanced equation. You must always start with this. Next step, convert quantities to moles, but do not convert impure substance to moles. Now, this is very crucial. For percentage purity questions, it is very important to read the question carefully to see which numbers are for the pure substance and which numbers are for the impure substance. The 5 grams over here belongs to the impure limestone. You cannot be sure whether the 5 grams is entirely calcium carbonate or not entirely, not purely calcium carbonate. You could not take 5 grams to divide by the MR because the 5 grams includes impurities. If it includes impurities, you cannot just take 5 grams divide by MR of calcium carbonate because you cannot assume that all 5 grams is calcium carbonate. There will be other things inside, silicon dioxide. Other things which are not calcium carbonate are also included in the 5 grams. So we do not convert the 5 grams to moles because of the impure substance. We are instead going to convert the 200 cm cube and the 0.4 moles per dm cube to mole. So the idea is we will convert what we know. The 5 grams, we don't know whether it's calcium carbonate or calcium carbonate with some other impurity. So the 5 grams, don't touch. Touch the 200 cm cube. First step, convert cm cube to dm cube by dividing by 1000. So that gives you the volume. And then times the concentration. And this will give me 0.08 moles of HCl. So this is the one that we convert to moles because we know that this volume, this concentration relates to HCl. Now, once you have converted to mole, the next step is really to use the mole ratio between HCl and calcium carbonate, which is 2:1. 0.08 moles of HCl is what we computed in the previous step. 2:1 means 0.08 moles is to 0.04 moles of calcium carbonate. This means there was 0.04 moles of calcium carbonate in the stone. Next step, find the mass of calcium carbonate. 0.04 moles times the MR. 0.04 moles times the MR of calcium carbonate, 40 plus 12 plus 3 times 60. And this will give me 4 grams. So we are trying to say that we have worked out using the reaction, there is 4 grams of calcium carbonate inside the limestone sample. Now, the last step is to calculate the percentage purity of calcium carbonate in the limestone. How do we do that? We already know there's 4 grams of calcium carbonate based on the mole ratio. But what was the mass of the whole limestone? The whole limestone sample was 5 grams, right? Out of the 5 grams, we have worked out 4 grams are calcium carbonate. Therefore, the percentage purity is 4/5 times 100, which is 80%. And that is how we get the percentage purity of limestone. Okay, percentage purity of calcium carbonate in limestone. So the idea always, step 1, balance chemical equation. Step 2, convert the quantities to moles. But remember, you can only convert the substance which you know, which is HCl. The 5 grams in this worked example, you do not convert to moles because you are not sure how much of the 5 grams is actually calcium carbonate. So we convert the HCl to mole. After that, use mole ratio between HCl and calcium carbonate to work out how many moles of calcium carbonate. Lastly, let's work out how many grams of calcium carbonate is this. And hence, the percentage purity is the mass of calcium carbonate, 4 grams, divided by the whole sample's mass, 5 grams, 4 over 5 times 100, which gives you 80%. All right, so that was the worked example on page number 7. Now, before we go, let me just do one more example for you, and that is actually inside checkpoint 3. Let's do question 10 together. Again, highlight chemical names. Chalk, impure calcium carbonate, very important. Chalk is impure, all right? So how do you determine the amount of calcium carbonate in chalk? You add hydrochloric acid to the sample of chalk. And in this case, instead of measuring the amount of HCl reacted, they measured the volume of carbon dioxide gas produced. So now we see the balanced equation is given to us, which is good. We don't have to write our own equation. You are told excess hydrochloric acid was added to 0.5 grams of chalk and 100 cm cube of carbon dioxide was produced. So these are important quantities. All right, 0.5 grams is chalk, but remember, chalk is impure. So do we convert the 0.5 grams to moles in the first step? If you recall, just now I said, during the worked example, for things which are impure, we do not convert to mole. So do not convert the 0.5 grams to mole because you don't know how much from the 0.5 grams is actually calcium carbonate. Remember, if it's impure, they are impurities. It's not all calcium carbonate. So we do not convert the 0.5 grams of chalk to moles. What we convert to moles is 100 cm cube. All right, so let's start. 10A, name an instrument which can be used to measure the volume of CO2 gas produced. And I think this one you know, it is the gas syringe. To measure the volume of gases, we always use the gas syringe. All right, now part B, calculate the percentage purity of calcium carbonate in the sample of chalk. So again, like I said, first step, balanced equation is given. So we just have to do the second step onwards, which is to convert to moles. We do not convert chalk to moles since it's impure. So let's convert our 100 cm cube to mole. It's volume of gas, so we use the triangle VN24. So N is equal to V over 24, but bear in mind, the cm cube has to be converted to dm cube. All right, and hence, this will give me the answer 0.00416667 moles. Please take note, this is 25SF. For intermediate working steps answers, we always round off to 5SF for intermediate steps. The next step is the mole ratio. Since we have calculated CO2, let's take the mole ratio of CO2 to calcium carbonate because you want to find calcium carbonate. The mole ratio according to the balanced equation is 1:1. 0.004167 moles is to 0.00416667 moles. So we also have 0.00416667 moles of calcium carbonate. The next step is to find the mass of calcium carbonate. This is easy. We take number of moles times MR. So 0.00416667 times MR. 40 plus 12 plus 3 times 16. And that should give us a comfortable 0.41667 grams. Okay, thereafter, the percentage purity will be the mass, 0.41667 grams, divided by the mass of the sample. The sample of chalk is 0.5 grams times 100. Okay, and we just need to compute this and we are done. All right. And that should give me 83 0.3% to 3SF. All right, so this is really question 10, how you would do question 10. Now for homework, I would like all of you to perhaps revise through this video once more, the main concepts, and thereafter, please complete questions 11, 12, and 13 that follow. All right, we'll stop at question 13. So please feel free to review this video to see how we can compute percentage purity when given data. Okay, if you have any questions, please feel free to approach me to ask as well. Thank you.